smaller than negative 6. But we were just looking for one number that would make it true. Let's go for this one. I'm going to put a 10 here. What's a quarter of 10?
2.5.
That is 2.5. What is 2.5 minus 3? I heard it somewhere over here.
Negative 0.5.
Negative 0.5. Can you tell me a number smaller than negative 0.5?
Negative
0.25?
Negative 1.
Negative 1. Can you tell me another number that's smaller than negative a half?
Negative 2.
Negative 2. Let's go for one more.
Negative 3.
Negative 3. Very creative. Right? All of those are smaller than negative a half. They are all solutions. The x value remained the same, but we had multiple y values that could continue to make that statement true. All right, last one for this page. We got 3x plus 4y has to be, what's that symbol mean?
Equal.
It means or it's something or equal. Greater than or equal to 12. Let's start with 0 for x. Can you think of a number for y such that when I substitute in, I will get a value greater than or possibly equal to 12? What value would you like?
3.
3. Now you give me 0 plus 12 is greater than or equal to 12. Is that true?
Yes.
0 plus 12 is bigger than or equal to 12?
Yeah.
Yes.
Yeah, that one works. All right, what if I substitute the value 2 here for the y? I know 4 times 2 is 8. What number could I use in the x spot to make that statement true? Yes?
4.
4. That would give me 12 here, plus 8 is 20. Is 20 bigger than or equal to 12? Yes, it would. All right. Let's use the 2 on this side. 3 times 2 is 6. I want a y value that would give me a value for the sum to be greater than or equal to 12. Yeah?
2.
2. Let's see, that would give me 6 and 8. 6 and 8 is 14. Bigger than 12. How about another one? Jared? 10? Let's see, that would give me 6 and 40. 6 and 40 certainly add up to more than 12. Perfect. Let's go for one more. Sabrina? 6? That would give me 6 and 24. 6 and 24 is 30. Adds up to more than 12. Again, same x value, multiple y values that will make my statement true. Notes section. Helpful information. Slope. At this point you've seen slope in your current math class. I expect you've seen it in your physics class. And you have multiple ways of expressing how do you determine slope given information. What's one slope formula that you are aware of? Yes, sir.
M equals y equals mx squared.
That is what we call slope-intercept form for a line. It requires the value of slope, but it doesn't tell me how to calculate the value for slope. But the M right here is that slope information. Yes?
Rise over run.
Rise over 1 is a very popular one. All right? Vertical change as compared to horizontal change. Another one.
Y over x.
How about delta y over delta x? You might have seen that in science class. What's the little delta mean, the little triangle? What's it mean?
Change.
Change. The change in the y values divided by the change in the x values. What's another one? I got space for 4. I see a hand way down in the back.
y2 minus y1 over x2 minus y1 or x1.
Very nicely done. All right, given 2 points, plug in the y values and subtract them, and plug in the x values and subtract them. And the fourth way, it's basically just the reversal of this. I'm going to switch the 1s and the 2s. I've had many students this year and in years past say, does it matter which point I choose to do the subtraction with first? No, it doesn't, as long as you're consistent. So I'm going to say we can also do y1 minus y2 over x1 minus x2. Two of the more bizarre types of lines to work with. I'm not going to say they're any more challenging, but they don't necessarily follow the same types of rules and patterns that we're accustomed to with the y equals mx plus b format, are our horizontal lines and our vertical lines. So I want to spend just a moment drawing extra attention to them and their idiosyncrasies. Horizontal lines. What do they look like? Like that. What do vertical lines look like? Straight up and down. What can you tell me about the slope of horizontal lines or vertical lines? They have some odd characteristics dealing with their slope. What do you know about it? What do you know? The slope equals zero. The slope is equal to the number zero. What's true about the slope of a vertical line? Sorry? The slope is tons to tons. If I were to write the equation for a horizontal line, what would it look like? Can you give me an example of the equation for a horizontal line? Yes. Y equals 2. What would be another example? Y equals 7. What would be another example? Okay. Y equals 0. Basic general rule. When we're writing an equation, we need y to equal something. Whether it's 2, 7, 0, whatever that number may be. We get y equals some something. Conversely, how do we write the equation for an inverse line? Yes, sir. X equals 15, x equals 16, x equals 0, x equals the majority of the lines you'll be studying are neither horizontal nor vertical. They are oblique. And this is where we get to use the slope-intercept form, which ties together our slope information and our y-intercept information. This is the format most commonly used. However, there are two other formats. There is what we call the point slope form and the standard form. Today is your introduction to those two forms. They each have their own utility, but they are describing lines much like y equals mx plus b does, but they have other abilities that make your life a little bit easier. Okay. Some quick notes there. Let's move on to the practice problems. Given 2 points, how